The periodic table is a truly amazing chart. It's like a big family album for all the elements in the universe. Everything you see, touch, and even breathe is made of these elements. The table organizes them into rows called periods and columns called groups. Elements in the same group share similar properties. Think of it like this. Everyone in your family might have the same color eyes or hair. In the same way, elements in a group react in similar ways. Group 1 is the very first column on the left side of the table. It's a special club and its first member is hydrogen. It's element number 1, the lightest and simplest of them all. Now, you might be wondering, why does hydrogen get that top spot in group 1? It seems like a very important position, and it is. The placement of an element on the periodic table is not random. It's all about its atomic structure, which means we have to look inside the atom. The elements in group 1 are known as the alkali metals. This family includes familiar elements like lithium, sodium, and potassium. They are all shiny, soft metals that are very reactive. Hydrogen, on the other hand, is a gas. That seems a little odd, doesn't it? A gas living in a family of metals. But science has a very good reason for putting it there. The story of hydrogen's place is all about its electrons. Electrons are tiny particles that zip around the center, or nucleus, of an atom. The way these electrons are arranged determines how an element behaves. It's like the rules of a game. The number of players and their positions decide how the game is played. For elements, their electron arrangement dictates who they will bond with and how they will react. The periodic table is organized based on these electron rules. So, to understand why hydrogen is in group 1, we first need to understand what makes group 1 so special. And it all starts with the number 1. So, let's get ready to explore this chemical mystery. We will look at what makes hydrogen tick. We will compare it to its neighbors in group 1, like sodium, which you might know from table salt. We will see how it fits in and how it stands out. The periodic table is a masterpiece of scientific organization, a map to the building blocks of everything. Hydrogen's position as the very first element in the very first group is the perfect place to start our journey. It's a simple element with a very interesting story to tell about its place in the chemical world. Consider this: the universe is mostly hydrogen, so it's pretty important. To really understand hydrogen, we have to zoom in, way in. We need to look at its atomic structure. Every atom has a nucleus in the center, which contains particles called protons and neutrons. Flying around the nucleus are the electrons. Hydrogen is the simplest element of all. Its atom has just one proton in the nucleus and one electron orbiting it. That's it. One proton, one electron. This simplicity is key. The number of protons is what gives an element its identity. Since hydrogen has one proton, its atomic number is 1. That's why it's the first element on the periodic table. Now let's talk about that single electron. Electrons don't just fly around randomly. They exist in specific energy levels, or shells. Think of it like a bookshelf. You can only put books on the shelves, not in the space between them. The first shell, the one closest to the nucleus, can hold a maximum of 2 electrons. Hydrogen has only 1 electron, so its first and only shell is half full. This is the most important clue to its placement in group 1. Every single element in group 1 has something in common. They all have exactly 1 electron in their outermost shell. This single outer electron is called a valence electron. Valence electrons are the rock stars of the chemical world. They are the electrons involved in forming chemical bonds with other atoms. An atom is most stable or happy when its outermost shell is completely full. Because hydrogen has only 1 electron, it has 2 choices to become stable. It can either lose that 1 electron to empty its shell, or it can gain 1 more electron to fill its shell. This desire to lose 1 electron is the main reason it acts like the other members of group 1. So when you look at lithium, element 3, it has 2 electrons in its first shell and 1 electron in its second outer shell. When you look at sodium, element 11, it has a full first and second shell, but just 1 lone electron in its third outer shell. Do you see the pattern? Hydrogen, lithium, sodium, potassium, they all have just 1 valence electron. They are all eager to give away that 1 electron to become stable. This shared characteristic, this single outer electron, is the primary number 1 reason scientists place hydrogen at the top of group 1. It's all in the atomic structure. Because hydrogen has that 1 valence electron, it often behaves like the alkali metals in group 1. The defining characteristic of alkali metals is that they readily lose their single outer electron to form a positive ion with a charge of +1. An ion is an atom that has lost or gained an electron. When hydrogen loses its electron, it becomes a hydrogen ion, which is just a single proton. This H+ ion is very common in chemistry. For example, acids are substances that release hydrogen ions H+ when dissolved in water. This behavior is very similar to how sodium acts. Let's look at a real-life example. Sodium reacts with chlorine to form sodium chloride, NaCl, which is table salt. In this reaction, the sodium atom gives its one valence electron to the chlorine atom. The sodium becomes a positive sodium ion, Na+, and the chlorine becomes a negative chloride ion, Cl-. Hydrogen can do something very similar. It reacts with chlorine to form hydrogen chloride, HCl. In this reaction, the hydrogen atom shares or gives its one electron to chlorine, much like sodium does. When dissolved in water, HCl forms hydrochloric acid, releasing those H+ ions. This ability to form a +1 ion is a classic group 1 move. Another similarity is the types of compounds they form. Alkali metals are famous for reacting with nonmetals from the other side of the periodic table, like those in group 17, the halogens. We already saw how sodium and hydrogen both react with chlorine. They also react with other halogens like fluorine and bromine in a similar 1-to-1 ratio. Lithium forms lithium fluoride, LiF, and hydrogen forms hydrogen fluoride, HF. This consistent pattern of forming similar compounds with the same elements is strong evidence for keeping hydrogen in the group 1 family. It bonds in a way that just makes sense for a group 1 element. So when we look at hydrogen from a purely chemical bonding perspective, it fits right in. Its tendency to lose one electron and form a +1 cation, a positive ion, is the signature move of the alkali metal family. It makes sense to group elements by how they react, and in many situations, hydrogen reacts just like its metallic cousins below it. For example, both hydrogen and sodium can be used as reducing agents in chemical reactions, meaning they donate electrons to other substances. This shared chemical personality is why, for over a century, chemists have agreed that the top of group 1 is the most logical home for hydrogen on the periodic table. Despite its similarities to the alkali metals, hydrogen is also famously unique. It's like the rebellious cousin in the family who does things its own way. The most obvious difference is its physical state. At room temperature, all the other group 1 elements, lithium, sodium, potassium, are solid metals. You can cut sodium with a knife. Hydrogen, on the other hand, is a colorless, odorless gas. It's a nonmetal. This is a huge difference. You can't build a wire out of hydrogen gas, but you can with sodium, though it wouldn't be a very safe wire. This physical difference makes some scientists question if group 1 is truly its best home. Furthermore, hydrogen has another trick up its sleeve. While the alkali metals almost exclusively lose one electron to form a +1 ion, hydrogen can also gain one electron. Remember how its first electron shell can hold 2 electrons? By gaining an electron from another atom, hydrogen can fill its outer shell and become stable. When it does this, it forms a negative ion with a charge of -1, called a hydride ion, H-. This behavior is very similar to the elements in group 17, the halogens like chlorine and fluorine, which also tend to gain one electron. This dual personality is unique to hydrogen. Let's think about some real-world examples of hydrogen's unique nature. As a gas, it is incredibly light. This is why it was once used to fill blimps and airships, like the famous Hindenburg. However, it is also extremely flammable. The reaction of hydrogen gas with oxygen in the air is explosive, releasing a huge amount of energy. This is what makes it a powerful rocket fuel. The main engines of the space shuttle were powered by liquid hydrogen and liquid oxygen. While alkali metals are also highly reactive, especially with water, hydrogen's reactivity as a flammable gas sets it apart. In conclusion, hydrogen's place in group 1 is a perfect example of how science involves compromise and classification based on the strongest evidence. While it is a non-metal gas and can sometimes act like a halogen, its fundamental atomic structure, that single valence electron, is undeniably a group 1 trait. The way it forms a +1 ion and bonds with other elements in countless compounds overwhelmingly links it to the alkali metals. Scientists place it in group 1 because its electron configuration is the most fundamental property used to organize the periodic table. Hydrogen is a unique element, a category of one, but its electron says it belongs at the top of the first column.